Okay, fourth example, last one. Other nonlinear systems. And quadratic, that's a misnomer. But I will never fix that in this PowerPoint, so whatever. Here we go. So you can see here, the second equation is linear. The top equation is a circle. It could be a hyperbola, it could be an ellipse, it could be whatever conic. It doesn't matter, okay? The thought process is still the same, okay? With some problems, you can use some sort of elimination method if you're a little bit more creative. Otherwise, if I have a line here, I'm going to use substitution. So here we go. Now, neither of these are set up for substitution. So that means I have to either decide to get X or Y by itself. Let's see what I decided because I don't remember. I chose to get X by itself because all I got to do is add Y. All right. If I wanted to get Y by itself, that was going to be 2 steps. So this is just 1 step. So now I can take this Y plus 6, stick it in there. And here we go. So I like to put slots. So imagine I put parentheses, blank squared plus y squared equals 26. And then to the blank, I replace x with y plus 6. Now, you've been down this road before. Remember, when you have y plus 6 squared, that does not mean you distribute the 2. No, no, no. If you do that, throw your pencil out the window, okay? Experience tells us that when, by definition, if you square something, that means you write it twice. So when you write this twice, you have to FOIL. So I multiply my y times my y and my y times my 6, and I distribute this 6 to the y and this 6 to the 6, and I end up with y squared plus 6y plus 6y plus 36 plus y squared equals 26. See how y plus 6 quantity squared does not give you y squared plus 36. It gives you all this lovely stuff in the middle. Anywho, combine like terms. And if we go back, you had a y squared and a y squared, which gave you 2y squared. And you had a 6y and a 6y, and that gave you the 12y. And 36 was all by itself. Now this is a quadratic. It's a polynomial. Under the polynomials branch of equations, experience tells you if you want to solve a polynomial, you have to get everything on one side, which means you have to move this 26 over by subtraction. So go ahead and do that. And we end up with 2y squared plus 12y plus 10. Now, before you jump right in and start trying to factor this by trial and error, look, all my coefficients are even. And this constant 2, which means I have a GCF of 2. So I always check for a GCF when I try factoring because I want to make my numbers smaller. Work smarter, not harder. So I have y squared plus 6y plus 5. Okay, so I'm going to see if I can factor this. Are there 2 numbers that multiply to 5 and add up to 6? Absolutely. 2 and 3. Whoa, I can't. I take that back. 2 times 3 is not 5. Whew. It's been a long night. 5 times 1, that's what I meant. 5 times 1 is 5, 5 plus 1 is 6. Anyway, I'm still bringing down the 2 because it doesn't vanish. All right, so now I put my factors that have a variable equal to 0. So remember, I'm not going to put that equal to 0 because number 1, that wouldn't make any sense. Number 2, there's no variable there. I'm putting these equal to 0 because I am solving for y equals. There's no y there, so don't magic y there. And definitely don't go off and say, oh, y equals 2. I don't know what the hell you're doing there. That doesn't make any sense. Okay, I'm solving for y. There's a y here and a y term here. Anyway, put those both equal to 0, and I get y values of -1 and -5. And just like before, you need to go back and get the x coordinates because if you're solving the system, they want an intersection point or intersection points, which means you need an x and a y coordinate. So go back. And again, it doesn't matter which one you choose, but I always choose the easier equation. And normally you would plug into the equation where you haven't modified it. But since I'm a math ninja, I can solve this one. I know I didn't make any mistakes here. X is equal to y plus 6. So I'm just cheating a little. And I want to plug in -1 for x and for y, I'm sorry. And plug in -5 for y the second time around and get what x equals. So when y is 6, I get x is 5. And when y is -5, I get that x is 1. And don't forget to write them as coordinates. And that's it. And did I solve this graphically? I don't think so. So that's it, peeps. Have fun.